Hello everyone and welcome to this new session which is about tape and offset surveys. Today you are going to learn how to use tape and offset technique to collect some measurements so that you can produce a plan or a map for a small area. So let's get started. I'm going to go through the equipment used for collecting the measurements, setting up control stations, and how to collect the wetness measurements, what are offsets, and how to perform the detailing procedure, and finally the booking sheets required for producing the plan. It might be useful before we start with the equipment used, guys, to mention that this method is simple and cheap, and it's useful for understanding the basics of surveying. However, it's not suitable for complete surveys, especially if you are working on a big area and it's required to do your work to a higher level of accuracy. It will not be suitable. But for us, it's very important to learn the principles of surveying through using this technique, which is tape and offset surveys. The equipment used. It is tape and offset, so we need tapes, as you can see here, a tape measure, guys. This tape measure, usually the length would be different from a tape to another. It might be 20 or 30 or 50 meters long. You might need some arrows like these to mark end of a tape. And sometimes if you are working on a long baseline, you might need ranging poles to range out a line, or what we call the baseline, between any two stations. And this is a ranging pole, as you can see here. And also you might need nails, hammer, and wooden pegs to fix any station that you are working on. Let's say now that you have an area like this one here. You have a fence, you have a road here, some other details, as you can see. Let's say this is a building, this is another building. Here we have some green areas or trees, some etc. And you've been asked now to produce a plan for this area. So first thing that you have to do is to set up control stations, and these control stations must form triangles, and the angles of this triangle should be more than 30 degrees for better accuracy. And the lines that you are going to run should be close to the details that you need to collect. Here we have details like buildings, trees, fence, road, so the baselines should be close to these details. And after that we need to collect wetness measurements that I'm going to explain later on. So we have this area. Let's set up now the control stations for this area. I'll pick this station here, another station, third station, fourth station, and then I will start to establish a baseline between each two stations. So each of these red lines here is called a baseline. So between each two stations we are going to spread a tape which is called a baseline, and all the measurements now would be relative to this baseline. So as you can see here, in this case we have established 4 control stations, and between each two stations we have established a baseline. This is a baseline, this is a baseline, and later on we are going to start collecting measurements or offsets relative to these baselines. And these control stations, guys, on the ground might be something like that. There might be a nail, as I mentioned, like this nail here, or a wooden peg. We have these wooden pegs, and this is another nail. So guys, if you are working on a project for a couple of days, for example, let's say that you are going to collect information throughout 4 days or 1 week, so you might lose the location of your control station. As you can see here, it's very easy to lose the location of this station. For example, it might be covered by mud or by plant leaves or whatever. So you need to make sure that you can relocate this station if you lost it because of any reason. And because of that, the witness measurements are very important, because they will enable you to relocate any control station that you established. What are witness measurements? They are two measurements or more than that for any control station like this one towards any permanent feature in your area. For example, I'm working here, I established this control station, and then I have this building close to this control station. I can take the first measurement relative to the corner of the building and the second measurement to this point of the entrance, so that later on, if I lost this control station for any reason, I can relocate this by getting just two tapes, and I will measure on the first tape 5.76 centimeters and on the other one 4 meters 0.95 centimeters, and then the intersection point of these two tapes will relocate my control station. So this is very important to relocate any lost control station. So these are called witness measurement. So after you set up your control stations in your area, collect the required witness measurements that will help you to relocate any control station later on if you would like to continue working on the project. So it's very important to establish the baseline to be straight. Okay, for example, if you have a long baseline like this one here between A and B, for example, in this case it is 73.70 meters. So in this case, because we know that the tapes would be 30 or 50 meters long, so one tape will not be able to cover the whole distance here. So because of that, we are going to use the ranging procedure to make sure that the baseline between A and B is straight like this, by spreading two or more tapes along the distance between A and B, and this is called ranging. Now after we establish the control stations A and B, okay, now we are going to spread a tape along the distance between A and B. This is a tape, this red line represents a tape measure here. So we have a baseline between A and B, so we will spread a tape, and then from this tape we are going to collect some measurements that are called offsets. They are just offsets from the baseline. For example, we are going to do some measurements to represent this fence. So this is the first point. We are going to measure the distance from the tape, from the baseline to the feature, in this case to the fence. Another measurement from the tape to the fence, etc. And these are called offsets, and they should be these two tapes. So we have a tape here to measure the distance between the feature and the baseline, and a tape along the baseline as well. And these two tapes should be perpendicular to each other. So now we have established everything. We are going to collect a lot of details for every single permanent feature in the area that we need to survey. So for each point we need to collect two measurements, guys. As you can see here, I have the tape here along the baseline. This is the first tape, and then for example this is the detail of interest, the fence again. So I'm going to use another tape. The zero of other tape should be on the feature. so 0 here, and then I will spread this towards the baseline, and this should form here right angle. Okay, and how to make sure that this is a right angle? You are going to wave this tape here, you are going to wave it like this, and then you are going to look at the reading at this tape, and the shortest distance represent a right angle between these two tapes. Okay, so this should be right angle by waving this tape to the right and left until you read the shortest distance, and that means that these two tapes are perpendicular to each other. And then you are going to collect two numbers for each point of interest. The first number along the baseline, so this is the baseline, here, this is our baseline between A and B. So I will collect the first number here. I will look at this tape. This is a tape, guys. I have spread a tape here. I will look at the number here. I will note it on my booking sheet, and then I will collect the other reading from the other tape from here to here, for example, and so on. And then for this point, for example, I will put the 0 of the tape here and then spread it to be perpendicular here. I will collect a reading along the baseline. In this case, if this is the 0 of the baseline, and then I will measure the distance from 0 to this point here. I will write it, let's call it y1 and then x1. So two measurements for each feature, and so on. Now let's say that we have this area, for example, and we are going to do some tape and offset work to produce a plan for this area. For example, we will need a booking sheet. Here I have the booking sheet. And then, guys, in this area I'm going to establish now a baseline. For example, I selected to establish a baseline between these 2 points here, point A and point B, along this curve, for example. Okay, so I established my baseline to be between these 2 points along this curve, and then from this curve, from this baseline, now this is my baseline. And all of my measurements now would be relative to it. Now if you look at the booking sheet, you have these 2 lines in the middle here. Okay, here in the middle, these 2 lines. These 2 lines represent the baseline. So in our case, here would be A and here it would be point B. Okay, so after we established A and B, we are going to spread a tape measure, as you can see here, along the baseline. So you can imagine that there is a tape measure here. So this is your tape measure between A and B. And then how to start collecting the measurement? Let's take this small area here. I will focus on this small area, for example. So I'm going to, for example, collect measurements for these 2 manholes. Let's take a close look. I have my tape here, the baseline here, point A, for example, and then the baseline along the curve, as you can see here. So this is point A. Now from A, I will measure a distance. So I will get another tape, the 0 of the tape here, and then I will measure a distance towards the baseline, and this should be right angle between these 2 tapes. And then I have now this to the left, this manhole, guys, here, for example, to the left of the baseline. So I will look at the reading here. For example, along the baseline I have a reading of 2.11 centimeters, so 2 meters point 11 from the baseline to this corner of the manhole. Okay, and then from the other corner of the manhole to the baseline I would say, for example, 2.60 for example, and then you can measure the dimensions of this manhole. So again here on reality I have along the baseline here 2.11, and then for example along this, the distance between this corner of the manhole and the baseline is, let's say, 1.65. I will write here 1.65, and then from this corner to the baseline, let's say it is 1.70. I will write here 1.70, and so on for the other one. And then you can measure the dimensions of the manhole. This will help you to double check all of your work. Let's say it is 50.20 centimeters. So if you are writing everything in meters, it would be better to use the same unit. Here I will write 0.5 and here 0.2. Now for the other manhole, this is just a sketch. It shouldn't be perfect. This is a sketch for you because you are going to use all of these numbers later to produce a map or a plan. You are going to measure the distance from this corner to the baseline, the distance from this corner to the baseline. Make sure this is a right angle, this is a right angle. All of your measurements should be right angles. Okay, along this one, let's say 3.21, and then the distance from the corner to here 1.90, and then here 3.73 for example, and then the distance from here to here, let's say it is 1.87, and then the dimensions of this manhole, you can measure them and then write them down here, and so on. Now let's return to the area that we started from. Now we map this one here. We are writing everything to the left because this is to the left of our baseline. So this is the baseline between A and B, which is here A and B along the curve, and all the details on the left here, all these details on the left should be here in this area on the left, yeah, and then all of the details on the right here should be here in this area. And these booking sheets for you, these booking sheets, guys, are for you, so you will use them later on to produce your final plan or your final map or this area. So now let's focus, for example, on this area here. We have a curve here, as you can see, guys. Here we have a curve, and then we have a curve here. To represent any straight line, you need two measurements. Okay, this is a straight line, for example. This curve is a straight line. So to represent this, I need just two measurements from the baseline. First measurement here, for example, to the baseline, and the second one from here to the baseline, and then on my map, so this is the curve here. Okay, this is the curved area. So to represent this curve, I need two measurements, one here and one here, for example. I will write down, of course, along this one 4.11 meters, and distance from here to here, let's say 8.34, etc. Okay, but for this curve here, guys, let's have a closer look. For example, this is the curve that we are working on. As you can see here, this is a curve. To represent a curve, we need more measurements relative to the baseline. You will identify a point to be a tangent point. Okay, so this is our curve. I will draw it here, for example, like this. I will say this is the tangent point, and at this point the curve will start. So I'll collect a measurement, and then another measurement here, another measurement here, another measurement here. So if you have a curve, you are going to increase the number of your measurements. The more that you collect, the more accurate the resultant curve would be. So it's better to collect as much as you can. So this is the baseline. So from here to here I'm going to do a measurement, and then from here to here, and then so that I can represent this curve in a good way. Okay, so here we have some complete example for this area, guys. Here, this booking sheet should be something like that. It shouldn't be exactly like that. In fact, you can just say, I don't need to draw all of these lines. For example, these two manholes that we have just covered, they are here. This operator, this surveyor, has measured the dimensions, has measured the distance to this point, but this point is not identified in a good way. It's better to measure to the corners. Yeah, along the baseline we have this measurement, and then from the manhole to the baseline we have this measurement 2 meters, etc. And here we have the curve. It's not, might be not clear here. So we look at the curve, and this is perfect work. They have collected a lot of measurements for the curve, as you can see here, which is very good to represent this curve in a good way. And this is a corner of a building. It's not clear here in this image here, but we have a building there. And to the right hand we have some benches here, some pathway, as you can see here, this pathway, this one. Okay, we have some benches. Look at this bench here, which is something like that here. Yeah, we have a statue. This is statue, I think. So this is an example. It's not the perfect example. In fact, it's a good one. Your sketch shouldn't be exactly like this. It might be more complicated, or you might say, I have a lot of numbers here, I would like to use more than one booking sheet. Of course you can use more than one booking sheet if you would like to simplify things to yourself so that you can read your drawing later on in a good way, because these measurements are very important, because you are going to use them later on to produce a plan for this area. So let's have a more detailed look. This is the same booking sheet, guys. This is the baseline between A and B. Here along the baseline here we have a lot of measurements to the left and to the right. Okay, these are the manholes again. Here we have the curve, and straight curve. Okay, here we have a building. We have some trees in front of the building. So for each permanent feature, this surveyor have collected sufficient information, sufficient measurements. And again, for each point, for each detail, you need two numbers. For example, for this tree, so this is the distance between the tree and the baseline, and this is the distance along the baseline. So feature, you need two measurements, one along the baseline and the other one the distance from the feature itself to the baseline. Okay, so let's say that you have collected all the measurements that you need for your area, and now you are going to decide on which scale is suitable to produce your final plan or your final map. So your final plan should be something like that, as you can see here in this example. These are the established stations, guys: A, B, C, D. This is to some extent big project. We have all of these stations around the project area, as you can see here. And then these people have established now a baseline between A and B, and they started to collect offsets towards the features. Okay, and so on. However, our final aim is to produce a plan similar to this in some way. To start producing the plan, we need first to decide on the scale used to represent all of the features that we have surveyed. Let's review what was the scale. Just quickly, the map scale refers to the relationship or the ratio between distance on a map or a plan and the corresponding distance on the ground. For example, if you have a plan with a scale of 1 to 1000, that means each 1 centimeter on the plan equals to 1000 centimeter on the ground. So you know that 1000 centimeter is 10 meters. Yeah? So that means each 1 centimeter represents 10 meters on the ground. And the scales can have different form. In fact, you might write the scale like this, 1 to 25,000 like this, and you can write it 1 centimeter represents 250 meters, or you can draw it like this, is called the graphical scale, something like that. Okay. Now, how to determine the best scale to fit a specific size of sheet or paper. For example, you have collected a lot of information about this area, and then after you collected all the information, you put everything together, and then you realize that the length of the area is 40 meters and the width of it is 25 meters, and you've been asked to produce a final plan on an A4 sheet. A4 sheet about 21 by 30 centimeters. So now we are going to decide what is the best scale to fit A4 sheet. I tried to simplify the thing for you so that you can do this for any kind of area size and sheet size. If you follow these steps, you can just identify the best scale to fit any size of paper. First, you are going to determine the geographical extent of your area. In our case, the geographical extent of our area is 40 by 25 meters. And then you need to determine the dimensions of your paper. In our case, it's A4 paper, so the dimensions 30 by 21 centimeters. The scale for the length, for L, is you are going to divide 30, which is the length of the paper, divided by the length of your area. So the length of the paper divided by the length of your area, in this case 30 centimeters divided by 40 meters. Let's just convert this meters into centimeters. We need to use always the same units. So 30 centimeters divided by 4000 centimeters. Now let's convert this to a scale format. Divide this by 30 and divide this by 30. We will have 1 to 133. And then for the width of the area, the same. The width of the paper divided by the width of the area, which is 25 meters in this case. So it is 21 centimeters for A4 sheet divided by 2500 centimeters, and then again we are going to convert this to the shape of 1 to something. So divide this by 21, divide this by 21, we will get 1 to 119. And as you know, there is no scale in reality using these kind of numbers, 1 to 133 or 1 to 119, etc. The common scales are 1 to 100, 1 to 150, 1 to 200, 1 to 250, 1 to 300, etc. Okay, so the common scale for this area should be smaller than the smaller one. The smaller one in this case is 1 to 133, so the closest thing to that is 1 to 150. Okay, and I would say this is the best scale to fit an A4 sheet, which is 1 to 150. So after you find the scale for the length and the scale for the width, as you can see here, we have 1 to 133 and 1 to 119. This is smaller, so because of that the common scale should be smaller than this number. Yeah, so, and as I mentioned, the common scale would have a form of 1 to 100, 1 to 150, 1 to 200, etc. So the scale smaller than 1 to 133 is 1 to to 150. So I will say in the end, so this is the best scale to fit an A4 sheet, which is 1 to 150. So once you found the scale for your area, so now I know the scale, which is 1 to 150. I'm going to start transferring all of the measurements that I have collected using tape and offset survey, or any other type of survey in fact, to my final sheet or plan. Okay, here we have the length of our area, which was 40 meters. We are going to convert this using the scale. Now 40 meters or 4000 centimeters divided by the scale 150. So the length of our area on the plan should be 26.6 centimeters. 40 meters would be represented by 26.6 centimeters. And the width of our area using our scale would be 16.6 centimeters. So the width of the area, 25 meters divided by 150, we will have the scaled measurement. Okay, so now I know the dimensions of my area using the best scale that I have decided on, which is 1 to 150. So in my case, the length would be 26.6 centimeters, the width would be 16.6 centimeters, and then all the details would be within this area. These are, for example, the borders of the A4 sheets here. These are the black line here, and then you are going to use your own sense the final layout of your plan. For example, you will decide to locate all of the map to the left here, left top corner, and then you are going to add the key of plan symbols or the legend, and here information about survey area. You can add your name, for example, here as a surveyor, and then you need to add the scale, and also you need to add the north direction. In this case it's not clear here, you might add it somewhere here or so. Let's say you need to use your artistic sense for the final production of your plan. Okay guys, so I hope that was useful today. I would like to summarize the whole thing from today's session. It was about tape and offset survey. If you have a small area that doesn't require a very high level of accuracy, you can use this technique, this very simple and cheap technique. In fact, you will need to establish first control stations around your area. These control stations, between each two control stations, you are going to establish a baseline and then to spread a tape along the baseline. After that, you are going to measure all the permanent features in your area relative to this baseline. And then you are going to decide, after you complete all of your measurements on your booking sheets, you are going to decide on the best scale to fit the size of paper that you would like to work on, A4 or A3 or A1, etc. What kind of size that you are going to use. After you decided on the scale, then you can use this scale to lay out the final plan or to produce the final plan for your area. And I provided an example on how it should look like, this final plan. It should contain some information about the survey area, about yourself, about the north direction, the scale used, and it should include, this is very important to know, it should include just permanent features. So on the final plan like this one, we don't add any baselines between any two stations. We don't draw this baseline. We don't draw any measurements. Yeah, as you can see here, just permanent features, buildings, trees, curbs, etc. Okay, thank you very much for listening and have a very good time. Bye now.